In this tutorial session, we are going to look at organic chemistry, and our topic of focus will be aromatic chemistry, specifically orthopara and meta directors. So let's get into it. Alright, so we are looking at ortho. Orthopara and meta directors. So this is basically under aromatic chemistry. And from our aromatic chemistry, we said this is just the chemistry that deals with ring structures. So when you're talking about ortho, para, and meta directors, we'll first try to break it down to understand what they mean when they say ortho para directors and meta directors. So let's start with ortho para directors. So ortho para director. So for us to understand this term very well, we need first to understand the position they refer to when they have a reference point on an aromatic chemistry. But basically, when they say orthopara directors, they simply mean that it is a certain compound on a certain position of the ring which donates electrons to the ring. So that is simply what they mean by orthopara directors. So in simple terms, we are saying that these donate electrons to the ring. So in as much as they are donating electrons to the ring, what they are simply doing to the ring is that they are just trying to activate the ring. So in doing so, what they do is they activate the ring. So this is basically what they mean by orthopara directors. So in a nutshell, we can say that orthopara directors are simply they are simply activating groups, or they are simply activating directors. So what we simply mean in a nutshell is that orthopara directors are simply they are simply activating groups. Okay, so now let's look at a structure of a benzene ring. So if you have a structure of a benzene ring, which is like that. As we know, a benzene ring is a six-sided ring. So we say it's in form of an hexagon shape with the conjugated double bond. So we will say this is our reference point. So let's assume this is our reference point. So if this is our reference point, we call this point as ortho position. Okay, so this is an ortho position. Then this will be our meta position. Then this will be our para position. Sometimes this group can be conjugated, or rather this group or this structure rather can be written in a different way, whereby we have a reference point maybe at this position. So we just need to know how to put these positions, as the next one will be ortho, then the next one will be para and meta, just like that. So it is not always that we'll find that the ortho position is just at this point. No, sometimes it can be at any position with regards to the reference point. So now let's look at some of the examples of certain elements or compound rather, which are considered to be orthopara directors. So I'll draw a benzene ring like this. So this is my benzene ring with those alternating double bonds. Then let's say my benzene ring is bonded to this compound. Okay, so we know that oxygen there has some lone pairs of electrons. So my benzene ring is bonded like that. So we can say that this group, because the element which is directly bonded to this ring, which is in this case oxygen, has some lone pairs of electrons. So these lone pairs of electrons can be donated to this benzene ring. And because this oxygen is donating some lone pairs of electrons to this ring, we are going to say oxygen in this case is donating electrons, and this entire compound in this case will be referred to as an ortho para director. Why are we calling it like that? Because if we look at oxygen, it has some lone pairs of electrons which can be donated to the ring. Now let's look at other examples of orthopara directors. So other examples, we're going to look at you might find a certain element apart from this one, apart from this. Also, this compound NH2, which is just a nitrite. So this is also an orthopara director, because this nitrogen has simply some lone pairs of electrons. Other than that, we have NHR. Still, this nitrogen has some lone pairs of electrons, so in this case it is also an orthopara director. Other than that, we can have hydroxide like this. Oxygen there has some lone pairs of electrons, so it is also an orthopara director. Or maybe we can have a ring, oxygen rather, like this. oxygen now bonded to a certain carbon chain. So we can just write it like this. So oxygen in this case has some lone pairs of electrons, so it is also an ortho para director. Now let's look at meta directors. So when you are talking about meta directors, for ortho para directors, we said they donate electrons to the ring. So meta directors, these they withdraw electrons from the ring. So they withdraw they withdraw electrons from the ring. And since they are withdrawing electrons from the ring, in this case we are going to call them their deactivators. So they simply deactivate. So they deactivate the ring. So because they are deactivating the ring, the meta directors can also be referred to as meta or deactivators or deactivating group. So they are also referred to as so also called so they are also called meta meta directors or deactivators or deactivating groups. So now let's look at some examples. Let's look at some examples of these deactivators. So some of the examples are when you have SO3, okay, when you have NO2, when you have NH4 plus, which is ammonium, when you have CF3. So all these are deactivators. This is simply a sulfite, then or sulfur trioxide, then this is just nitrogen nitrate rather, then this is or nitrogen dioxide, this is ammonium, then this is the carbon trifluoride. So all these are simply meta directors or they are deactivating groups. So we have an exception here. For example, if you have halogens, let's talk about halogens. So halogens are simply the exceptions we have. Initially we said that meta directors are deactivating groups, but when you are talking of halogens, for example, when you are talking about chlorine or chloride rather, when you are talking about fluorides, when you are talking about bromide, or maybe when you are referring to iodide, these of course they are deactivating groups, but they are ortho para deactivators. So these are ortho para deactivators. So they are ortho para deactivators, except that these are also able to withdraw electrons from the ring, but there is an exception for this one. These are simply special. So as much as they are withdrawing electrons from the ring, deactivating the ring, they are ortho para directors. Now let's look at some questions. Let's look at some questions which we must be asked in exam. So examples. So in these examples we'll be determining. So determine whether Ortho determine whether Ortho, para, or meta directors. So we are going to be determining whether a certain compound attached to the benzene ring is an orthopara director or meta director. So let's start with this one. Let's say we have this group. So this is the structure. We have a benzene ring like that. Then this benzene ring is attached to this structure. Okay, so it is bonded to oxygen. Then we have a methyl group. Okay, so what can you say about this structure? You can say that oxygen has these lone pairs of electrons. Because it has these lone pairs of electrons, it can donate to the ring. So since it is able to donate electrons to the ring, we are going to call it an ortho-para director because it will be activating the ring. So this one, it is ortho-para director. Okay, so let's look at another example. Let's say we have this structure. So this will be our B. So we have a benzene ring. So this benzene ring is attached to this group with a double bond there. Okay, let's say we have oxygen there, then bonded to another oxygen with a methyl. Okay, so what can we say about this structure? We can say that the element direct bonded to this benzene ring is simply a carbon, and carbon in this case, it is carbon is has an hybridization, or it is sp3. Like for this one, the carbon there, it is bonded like to 4 things. So according to the variance of carbon, it is tetravalent, but since it is bonded to all the 4 things, we can see that there is a double bond there. It is like this. There's a double bond there, then bonded to this thing and that thing. So all the bonds of carbon are 4. So since they are 4, we are going to say this carbon does not have any free electron which it can donate to the ring. So it will be withdrawing electrons from the ring. And because it is withdrawing electrons from the ring, we are going to call it a meta director. Okay, so let's look at another example. Let's say we have this structure. We have a benzene ring like that. Then it is attached to oxygen. Then this oxygen is bonded to another oxygen, then with a methyl group there. So you can see that this oxygen has lone pairs of electrons because it is the one which is directly bonded to the ring. That is our main focus, and because it has these lone pairs of electrons, it is able to donate these lone pairs of electrons to the ring, hence activating the ring. So you can say that this is an ortho-para director. Okay, so it is ortho para director. So let's look at another one. So let's look at this structure. We have a benzene ring like that, then we have nitrogen, then we have lone pairs there. Okay, this nitrogen is bonded to hydrogen, then bonded to carbon, which has a double bond with oxygen, then like that. So our main focus, again, our interest is that nitrogen, which is directly bonded to this benzene ring, and because this nitrogen has a lone pair of electrons there, it is able to donate these lone pairs of electrons to the ring, hence activating the ring. So you can call this as ortho para director. So it is ortho para director because it is able to activate the benzene ring. Let's look at another one. Let's say we have this question. So we have the double bond, the benzene ring there with alternating double bond. Then this is bonded to a chlorine. Okay, so we can see that this chlorine has some lone pairs of electrons which are not involved in bonding, but in the actual sense, this chlorine, we categorize it under deactivators. Okay, we categorize it under deactivators. It was under meta, but this chlorine has lone pairs of electrons which can activate this ring, but instead of it being a meta director as a halogen, this chlorine is able to, of course, donate electrons to the ring. Okay, so instead of it deactivating as an halogen, this one, of course, it will be deactivating the group, but it will be an ortho para director. Okay, so oxygen is still, chlorine is still an ortho para director, regardless of it being able to donate electrons to the ring. It deactivates the ring. That is an exception with halogens. They deactivate the ring, but they can be able to donate electrons to the benzene ring, but in this case we call them ortho para directors. Then the other one we'll look at is this structure, which was asked in the tutorial sheet for aromatic compounds. So we had a benzene ring there with sulfur. This sulfur is bonded to oxygen with a double bond with another oxygen there. Then we have oxygen bonded to hydrogen. So this was the question. So we can see that this sulfur is bonded to 2 oxygen. In short, it is bonded to 3 oxygen because we have this oxygen, that oxygen, that oxygen, and also it is attached to the benzene ring. So from this sulfur, if we count the number of things, or if we count the valence of sulfur is found in a group where there is oxygen. It is also found just below oxygen. That should be in group 6 if we check on the periodic table. Now, from the structure we've been given, we can see that this sulfur does not have any lone pair of electron. So because it is lacking any powerful electron, this sulfur is able to withdraw electrons from the ring to itself. And because it is withdrawing electrons from the ring towards itself, we say that it is deactivating the ring. And because it is deactivating the ring, we call it a meta director. Okay, so this is where the orthopara and meta directors ends. So we end here with this part of the aromatic chemistry.